This one here is going to be about IPv6 routing. So it's basically a simple introduction into how to configure IPv6 on IPv6 routing protocols on basically 3 different operating systems. Before I get into that, just a reminder about voting. I sent the email to NANOG, but I know quite a few folks probably don't read NANOG announce. So please read the screen. If you're interested in voting, I hope you all are. The steering committee positions, 7 candidates are standing for the 3 available positions. And there are also 3 charter, slight tweaks to the charters being proposed. If you'd like to go and indicate your opinion about those as well, that would be greatly appreciated. So I've put the URL up on the screen there. You need your NANOG username, password, the same one you use for registering to access that website. Polls close at 1 o'clock tomorrow, so you don't have much time left. All right. So this is IPv6 addressing and routing protocols. It's really intended as an introduction. I'm not going to get into really complex, convoluted configurations and so forth. It's really meant to be a kind of primer for those of you who haven't really touched v6 before, or maybe have started to touch it but aren't quite sure what you need to do. Ron Bonaker from Juniper and I put this together, was it 2 years ago? I think it might have been 2 years ago, again at the joint NANOG ARAN meeting, but we gave it actually as one of the ARAN tutorials. So Ron has worked on all the Junos configurations. He unfortunately can't be with us today. Please don't ask me about the Junos configurations because I really can't help you. But I'm sure Ron or any of his colleagues who are here today would be delighted to assist offline. So the slides, well, I've put them up on my FTP site there. They're actually on the NANOG 44 website as well if you want to follow along. So what we're going to look at, I'm going to take a look at some addressing plans for IPv6. This is just kind of giving folks some general indication of what I see people in the industry doing. I'm not saying that this is what you should do. I'm just saying this is what I see ISPs do. I find that one of the biggest barriers to some of the deployment, at least what people tell me, is that, we don't know how to do the addressing plans. 128 bits is huge, and I'm confused. So I've tried to reduce the confusion a little bit. We then look at how we just generally configure IPv6 and then do the IPv6 routing protocols overview. So we're looking like sort of OSPF, ISIS, and BGP. Going to cover 3 operating systems, so iOS, iOS XR, and Junos. Hint to anybody else with other operating systems, if you'd like to have your bits in here, I would love your contributions. Because then if I can get something that covers all the major operating systems, quite happy to add these in the slides as a general archive for the community. Okay, so let's look at the addressing first. So where you get your v6 addresses from, the regional internet registries, and if you're a member of, well, most of you will be a member of ARAN, you can go to ARAN, get your v6 address. You don't have 101 questions to answer as you do for IPv4 address space. It should be reasonably straightforward. If you're not a member of ARAN, you can become a member, or you can go to your upstream ISP and get address space from them. But generally, I think, for anybody who's providing services, so service providers, you probably should get your own independent address space because I believe it tends to make multi-homing and everything else a lot easier down the path. You can also use 6 to 4. I'm not really going to touch on what that is too much. That's the alternative. If you have a routable v4 address, you can try and use 6 to 4. Registry regions, just in case you didn't know where they were. So, pardon me, getting the v6 address space, as I say, become a member of your regional internet registry, get your own allocation. Generally, you require a plan for a year ahead or thereabouts, depending on which registry you go to. And actual allocation policies will be documented on each registry's website. So they are subtly different, but the general principles are pretty much the same. There is actually plenty of IPv6 address space. I won't say they're endless amounts because the current policies probably are working or attempting to work through the v6 address space probably faster than some folks expected, but there certainly is plenty of it, not like the situation we have with v4. If you get from your upstream ISP, you would generally get a single /48 from them, unless you can demonstrate that you're going to need more. Of course, a /48 gives you 65,000 subnets. If you have more than 65,000 subnets in your network, then you probably can get another /48, and so on it goes. As for 6 to 4, you take a single public IPv4/32 address, put 2002 in front of it, that gives you your /48, and that gives you 65,000 subnets that you go and play with. So that's the sort of thing I've done at my house. In Australia, my ISP kind of goes, what's IPv6? But they kindly give me a routable v4 address. They don't NAT me yet. So I just use 6 to 4, and that works all quite nice and easily. So I've got 65,000 subnets for my house. Anyway, so let's look at how we do some of the actual addressing. These are just kind of general guidelines that I've seen people do. I'm not saying that this is what you should be doing, but these are general guidelines what I see folks doing. Address block for all the router loopback interfaces. I mean, pretty much these days in v4, you've got a /32 for each loopback. So for v6, a single /128 for each loopback, and you can number all the loopbacks in your network out of a single /64. And that allows up to 2 to the power 64 routers, which is probably enough for the time being. Then you set aside an address block for infrastructure. Now, I guess see different ISPs do different things. I mean, a single /48 gives you 65,000 subnets. That's quite a lot of infrastructure. If you think about point-to-point links, joining routers, LANs, and all the rest. But I mean, some ISPs will use a single /48 for the entire infrastructure. Others will use a /48 per point of presence, because I suppose they imagine they'll use all 65,000 subnets in that POP. Some of them will probably use a /48 for a region. So it could be like a few cities, or maybe, for example, here in the US, it could be a state or something like that. So it tends to vary. There's no hard and fast rules. You need to try and figure out what is sensible for your own network infrastructure growth plans. What about LANs? Well, that's simple, /64 per LAN, end of story. That's pretty much the expectation. It's pretty much what I see everybody is doing. You don't have to do this, but bear in mind if you use something that's smaller than a /64, e.g. a 96 or 120 or something, a lot of things are not going to work properly on the actual LAN. So generally keep life simple, /64 per LAN, and you're good. What about point-to-point links? Well, there's been a lot of debate about point-to-point links. It's kind of wandered around in different places. Again, looking at what ISPs are doing, some people are using /64s, which is kind of the expectation of the developers of v6. Some people have used /126s quite happily, but it has been pointed out that mobile IPv6 home agent discovery won't work. And some people go, well, I don't care about that. They're quite happy to use /126s and just ignore the whole mobile IPv6 thing. Some people are using /112s, which will still ensure that mobile IPv6 home agent discovery works. It leaves the final 16 bits free for various other possibilities that could be coming along. And there are even some people thinking about /80s or /96s or various other combinations. RFC 3627, it's pretty old now, but there was some discussion there about well, what people should or should not do for point-to-point link addresses. What's the right answer? I quite honestly, truthfully, do not know what the right answer is. It's still quite early in the piece. As some of you know, I do quite a lot of workshops teaching v6 routing and so forth, and in those, I just use /64s for the point-to-point links. Then at least I'm working the principle of least surprise. There isn't anything in the future that's going to come along that's going to cause me to renumber my /126s into something else. And it would be majorly painful to try and do that if I had to do it. So anyway, so that's really what I see folks are trying to do. As for customers, well, they get a single /48. That's probably simple, but then again, I see some ISPs who are saying, oh, well, you're quite big to get a sorry, quite small to get a /48. 48 is a bit big for you. Maybe you should get a /56. And so I see some kind of slicing and dicing happening on that side as well, which I don't think really was the intention of the developers originally. So you see 56s going out there, you see 6days going out there. Kind of what is the definition of a customer? I mean, does a broadband customer with 3 computers at home really need a /48? So there is some kind of discussion going on in various parts of the world about that size. But anyway, customers get one /48. If a customer needs more than a single /48, then they're probably pretty big, like they have more than 65,000 subnets. And generally, as for v4, I mean, this is again my preference. Try not to do the reservation of address space on a per point of presence basis. I mean, you're using IBGP to carry a lot of the customer address space around, so a lot of people tend not to be aggregating this on a per pop basis. And of course, if you are aggregating on a per pop basis, then you probably want to try and reserve chunks of /48s per pop. So I've tried to draw a pretty picture that sort of explains this. The transition hasn't worked, but that's a shame. But anyway, phase 1 is the top part of the picture. Basically, I've tried to show a /32 here. The loopbacks, I've picked the first /64 and the 32 address block. And then I've picked the first /48 for the service provider infrastructure. Why did I do that? Well, laziness, really. I started off doing v6 workshops about, 5-6 years ago, and actually used the top end, because that's kind of what I did in v4. I used as like a last whatever bit of the v4 address space, just because, well, no reason really. But I found that typing in these big addresses with lots of FFFs and so forth were prone to errors. So if I pick the first /48, the v6 address becomes nice and short, less typing to do, less chance of errors. And that's just been borne back by the experience from the workshops and some of the initial deployments I've helped with. If you get your second /32, which is meant to transition properly, like now, but it didn't quite, there's every chance that the registry will be able to give you the adjacent /32. And so you could, again, pick the first /48 for your infrastructure to keep the numbering nice and simple and give the rest of it to your customers. So this is the kind of planning that I see people doing and trying to encourage other people to do as well. It's slightly different from how folks will handle v4. And it's mostly because of the relative ease of handling the shorter addresses at the start. Okay, now, so I say, registries will usually allocate the next block along to try and make it contiguous with the first allocation. There's no guarantee that they will do that, but there's every likelihood that they can. Then there's a whole documentation piece, document infrastructure allocation, generally makes operation for you easier, makes debugging easier, management easier, and so forth. Document the customer allocation, obviously internally, so you know what's going on. Just generally makes the whole thing easier. Some folks will put the network object in the RIR database, others put it in their own database, and others do nothing at all. Generally up to you. Okay, so getting the initial v6 configuration going. So we'll start off looking at iOS. So the global command to switch on v6 is basically IPv6 unicast routing. It's not enabled in iOS by default. One of these years, it might actually change. Those of you who are as old as me will remember when iOS didn't do IPv4 routing by default, and you actually had to go and do IP unicast routing. So this is the same for v6. To switch it on, IPv6 unicast routing. For some reason, Ceph is not enabled by default, even though it's default for v4, so you need to go and switch that on. And then pretty much I see a BCP these days is to disable the IPv6 source routing, which again is on by default. So you need to do no IPv6 source routing to switch that off. If we look at XR, which is a variable in the higher end boxes, well, v6 is actually on by default. So that's actually relatively straightforward. It's there already. So configuring interfaces is the same for both operating systems. You just basically do IPv6 address, and then you type in your lovely hex number / the prefix mask. You can also configure EUI64 addresses if you really want to on a router. I don't know why anybody would want to, but you can do it if you do. It just makes the v6 address really long, and it makes your network harder to manage because, well, if you change interface cards, you've got to change all the v6 addresses. I don't really recommend this. It's much better to do static addressing on any router interface. We look at the GNOS equivalent, again, relatively straightforward. You go into the INET6 family and you just drop in the address there. So pretty much what you do in v4, you mirror the equivalent for v6. And as with XR, IPv6 is on by default in GNOS. To configure something dual stack, we simply go into, well, the INET is the standard for the v4 address, so we just pop the v4 address there in the INET family, and the v6 address sits in the INET6 family. So you can see the two addresses sitting side by side. So configuring v6 is quite simple. If you want to configure an EUI64 address, again, usual caveats, you just specify EUI64 at the end there. Once v6 is up and running, well, you can do various services, so things like name server, syslog, TFTP, and so forth are v6 accessible. Paradoxically, in iOS, it says IP name server, whereas you'd expect it to be IPv6 name server, but it's IP name server, and you can put in a v4 or a v6 address if you want to. XR does away with the IP and just calls it domain name server, which is a lot more sensible, as does GNOS, just calls it name server, and you can specify v4 or v6 addresses. I mean, you don't have to have a v6 resolver to get v6 responses from a name server. A v4 name server can quite happily give v6 responses. Okay, one thing to note, for enabling v6 on any platform, be aware that IP access to the control plane is now possible over IPv6 too. I see quite a few folks quite happily switch on IPv6 unicast routing, come away from one of these tutorials. They're carefully crafted filters to protect the control plane. They're beautiful for IPv4. They're non-existent for IPv6. I was hearing somebody say the other day that, well, the bad guys probably have a much better v6 understanding than a lot of the good guys have. So make sure your router is not wide open to the world in v6, even though it's locked down in v4. So if you're doing any v4 filtering, make sure you supplement them with v6. Now, when you actually activate an interface with v6, for example, with the iOS configuration there saying IPv6 enable, you will automatically get what's called a link local IPv6 address. So every interface will have that, whether you configure a real v6 address, or in other words, a global unicast v6 address, you will always have a link local address there as well. That's one of the differences between v4 and v6. The connectivity between devices is done at the link local level. So be aware that you'll also have an FE80 address appearing on the router. I mean, those of you who've got likes of Macs or Windows Vista and so forth, you can see that on the interface there. You will see your v4 address, you see your routable v6 address, as well as this FE80 link local address. So the routers are no different. And so here's an example. We just switch on v6 unicast routing in iOS and activate the interface, and we see that FE80. I mean, I've got a pointer here, but which of the four screens to point to, I don't know. But you see the FE80 address there about halfway down on the right-hand side of the screen. FE80, double colon, and then that rather big thing, which is basically the MAC address of the router with an FFFE inserted in the middle. So that basically takes the MAC address and converts it into, well, the EUI64 format that v6 uses. So you will see those, no escape from them. So giving a router a real address, in this case it's an EUI64 address. You'll see in the show interface status that it actually says, look, you've configured me an EUI64 address out of the 2001 DB8/64 address block. And so you get this, you see near the top on the left, you see this rather large IPv6 address there. So if you do want to use EUI64, that's the sort of size of addresses you'll be dealing with. That's why I tend to find the operators these days who are switching this stuff on opt to try and keep the addressing as simple as possible. If we look on iOS XR, you see similar things. This one is also EUI64 interface, so just done a show IPv6 and interface. You see the subnet that it's in, and you see the link local address, and so forth. And on Junos, so again, similar things here. If you look a bit further down, you see the link local address, and at the bottom you see a configured interface address. Okay, let's look at the routing protocols. Well, one thing you'll find with a lot of configuration for v6 on routers is whatever you did in v4, it's virtually the same for IPv6. You just replace whatever the IP commands were, or the v4 address family commands, with the equivalent IPv6 or IPv6 address family commands. So in that sense, it's relatively simple. So here's a v6 static route in iOS. So rather than IP route, as you have for v4, you do IPv6 route. You've got the destination, you've got the next hop address, and then you've got the administrative distance that you want to attach to the static route. XR, slightly funkier configuration. You go into router static, then you go into the v6 unicast address family, then you put in the destination, the next hop address, and again, the administrative distance. And Junos is pretty similar configuration again as well. We go into the next one, which pretty much shows you how to do it. For static routes, we go into the INET 6 rib, we go into the static subconfiguration, we set up a route towards 201 dB8, specify the next hop, and we specify the metric. Okay, so you recognize this from v4, you just see it using the INET 6 address family instead. Default routing, this is about the only thing in v6 that's shorter than in v4. The default route in v6 is just :/0. So fewer characters than 0.0.0.0. So configuring a static default, for example, in v6 is pretty much saying IPv6 route, :0, and then the next hop destination. Doing it in XR, well, again, we've got the address family, go into router static, the address family, v6 unicast, and then the default route specifying the next hop as well. And the Junos configuration, similar idea. We go into the INET 6 rib, set up the static route, default, and the next hop, basically the address of the R2 Ethernet in this example. Dynamic routing protocols. Well, dynamic routing is actually unchanged between v6 and v4. We still have the same two types of routing protocols, the interior routing protocol and the exterior routing protocol. And IPv6 still uses the longest match routing algorithm. We've got the same or similar IGPs. We've got RIP next generation, that's described in RFC 2080. We've got Cisco EIGRP, which obviously is only supported on Cisco iOS, not on Junos or anything else. We've got OSPF version 3, and we've got ISIs now supporting IPv6 as well. I mean, if you're watching your RFCs, I think RFC 5308 came out about 4 or 5 days ago. So that's now got a nice little RFC document to go with it. As for BGP, well, we just have BGP. RFC 4760 and 2545 cover the necessary extensions for BGP to support IPv6. Configuring it in iOS, well, this won't be any surprise to those of you who use this operating system. Dynamic routing protocols require router ID. Router ID is a 32-bit integer which uniquely identifies the router on the network. iOS will automatically generate this from the loopback interface if one is configured. Otherwise, it just picks the highest IP address on the box at the time, highest IPv4 address on the box, at the time the routing protocol is started. Most ISPs are going to deploy IPv6 dual stack, so they're going to add IPv6 on top of an existing v4 network. They're not going to say, ooh, I'm going to be the world's first IPv6 only ISP, at least not yet. And I mean, certainly it was interesting a few years ago when people were heading off down that path. They ran into the whole issue of, well, routing protocols all beautifully configured, but no router ID, so nothing actually worked. These days, most people I know are deploying dual stack. So you're going to have your router ID there anyway. Some people will manually configure the router ID because that's their operational policy or practice for doing so. So in that case, you just specify the router ID command as I show in the example there. XR, well, for v4 routing protocols, again, XR will automatically generate the router ID. But BGP requires it to be manually configured, so there's one example. So for example, router BGP, well, I've used the extended AS example here, the 32-bit AS example, putting in a router ID manually like that. Also, OSPF v3 requires the router ID to be manually configured, at least on the box that I'm using. So it's slightly more. You probably have to watch exactly what's going on here. Some of them required and some of them don't. As for Junos, the user can and should, this is Ron's advice, configure router ID explicitly. So again, you just put the router ID, specify the IPv4 address. The router ID is a 32-bit integer. It's just convenient that an IPv4 address is also a 32-bit integer, which is why it's used. It doesn't have to be an exact mapping between router ID and real v4 addresses, routable v4 addresses, as long as the router IDs are unique on each router on the network. And if the user doesn't explicitly configure the router ID, then the loopback interface address is used. Now, RIP-NG. Well, ISP industry, you simply don't want to go here. If you're around in 96, 97, and so forth, and you played with the 6-bone, as I did, you'll remember the early 6-bone used RIP-NG. And it worked at the time, but I think it was very good encouragement for folks to actually extend BGP to handle v6. So I tend to call RIP-NG as rest in peace, next generation, and that's pretty much how I think ISP should be treating it. It really doesn't have a place in a service provider network. So I'm not going to cover it here. I'm not going to show any examples because, well, EIGRP, okay, this is Cisco iOS specific. Basically, EIGRP already is multi-protocol. It handles all these other things, IP, IPX, AppleTalk, and so forth. So it's just a case of adding in the IPv6 protocol as well. So the 3 new TLVs. Router ID is still 32-bit. Protocol is still number 88. CLI looks the same. So it's an iOS 12.4 if anybody's interested or still plays with this. It's not an XR yet. I don't even know if it's ever going to make it. So there's some differences. I don't really want to bore you with them, but looking at the configuration, remember v4 would be router EIGRP something. So for IPv6, you just do IPv6 router EIGRP something. And then you basically specify which interfaces are going to participate in EIGRP as an example there. The display, well, rather than show IP EIGRP neighbor, we've got show IPv6 EIGRP neighbor. The neighbors are identified by link local addresses. Now this is one thing that certainly some of the recent adopters I've been working with have said, oh my gosh, you're joking. Is it really like that? How am I meant to know all my neighbor link local addresses around my network? This is one thing that's actually different. In v4, we tend to have a routable v4 address that you actually can figure out. Or it will, depending on the routing protocol, it might specify which interface and so forth. But in v6, it says, well, my neighbor has this link local address. And I know most people don't carry link local addresses and MAC addresses of routers around in your head. So it'll add an extra layer of troubleshooting challenge, let us say. I honestly don't know why it actually can't also specify a real v6 address in there as well, but the spec says neighbors are identified by link local addresses because, of course, all the routing protocols and connectivity works per link local. Moving swiftly on, OSPF version 3. Okay, OSPF version 3 is OSPF for IPv6. It's based on OSPF v2 with enhancements. It carries v6 prefixes. It does not carry v4 prefixes. Same as OSPF v2 does not carry IPv6 prefixes. If you know what it means, it ships in the night with OSPF v2. I think that goes back to like 17th or 18th century when sailing ships didn't have lights and so forth. So basically there's no interaction between the two OSPF processes. One simply has no idea that the other one is there. Okay, so what's changed? Well, a lot of it is very similar. We've got all similar packet types, same ways of discovering neighbors, same interface types, the way the flooding and aging of LSAs works, very similar LSAs as well. There are a few extra ones. One interesting difference is that OSPF v3 runs on a link rather than per IP subnet. So link basically is, well, the connection between two particular devices, how they communicate with each other at the link layer. So this is actually a lot handier than, well, certainly those of you who've used OSPF, certainly on iOS, where you have to do the whole things of passive interface, no passive interface, network statements, and the masks have to match with interface addresses, or maybe they don't have to match and they might still roughly work. It's quite confusing for newcomers trying to configure OSPF. Whereas if you do this running it on the link layer, as you'll see in a few slides' time, it's actually very, very easy to set up, and it just looks like setting up ISIS, in fact. You can support multiple instances per link, because, of course, rather than just running on a subnet, and now you can run multiple instances on a link, so you have different OSPFs per link if you wish. What else? Various semantic changes within LSAs. Who cares when we're running networks? It doesn't affect anything that we do, but if you're looking at the actual protocol design, you're probably interested in this. Generalized flooding scope, well, that's slightly different. What else? Explicit handling of unknown LSA, that's probably quite important. Makes OSPF v3 extensible, so if someone comes along and says, oh, we need this new LSA, you don't have to go and upgrade all the routers in the network just to support it, because in OSPF v2, at least all the current implementations as I'm aware of, if you introduce a new LSA, you have to upgrade all the routers in your network to support that new LSA type. Whereas with OSPF v3, the LSA is just flooded, just passed on. Pretty much like BGP passes on unknown attributes. Authentication has been removed from OSPF, so it's just pretty much relying on the v6 authentication header now. What else? Packet formats changed. 2 new LSAs. Not really going to look at those. So configuring OSPF in v3 and iOS. Well, rather than doing router OSPF, we do IPv6 router OSPF. Interfaces are configured directly. You've got no more network commands. I mean, can you imagine typing the network command for all these like big long addresses? Probably not too easy to do. And it's a native IPv6 router mode. That's, I suppose, done simply because OSPF v2 and v3 have no interaction with each other, so it was considered better to have them completely separate. Those of you who have already looked at some of this, you'll find that the IPv6 router OSPF configuration for some reason appears right at the bottom of the iOS configuration display, which is probably not helpful. So entering the router mode, we've got IPv6 router OSPF, we've got the process ID. In the interface mode, we then go into the interface and do IPv6 OSPF, which process ID we want to use and which area the interface will sit in. The show commands and the clear commands are like the v4 versions. We just had to add in the v6 extras. We can look at various OSPF show things. The configuring authentication a bit further down, so it just uses the v6, I suppose one of the IPsec authentications within v6. Not that sophisticated, but at least it gives you the neighbor authentication if you so desire. So looking at a real configuration example, we've got 2 routers here, 2 different areas. Looking at router 1, which is parked there between area 0 and area 1. So interface pos 11 is sitting in area 0. So all we have is IPv6 router OSPF 100. 100 is the process ID. Interface pos 11 is sitting in, where is it sitting? Area 0. So we just do IPv6 OSPF 100 area 0. And pos 20, which is sitting in area 1, is IPv6 OSPF 100 area 1. So those folks using ISIS will recognize this and go, OSPF has done something sensible at last. Interestingly enough, you can now do all this kind of thing in the OSPF version 2, certainly in iOS. So if you're using OSPF in iOS, you can do this style configuration as well, which is an order of magnitude simpler than the old style. Looking at the v6 OSPF route, well, just looking at the v6 routing table, OSPF v3 again is just indicated by the O entry on the left there. And as I mentioned before, look at the next hop addresses, the link local addresses. They're no longer a real routable address anymore. And so the people who have been deploying this and have been doing workshop with go, does it really have to be this? At least you get the interface listed there, but, you know. So what devices, FE80, 2D0, FFM, and so forth? I mean, as I said before, you don't go carrying MAC addresses around in your head. That's just how it is done. Okay, you can run OSPF v3 over tunnels if you want to do that. So that's a configuration how you might want to do it if you're still trying to tunnel things over your infrastructure. Moving on to XR. So different folks doing the coding here. So they've called it OSPF v3 as the process. So rather than router OSPF for v2, we've called it router OSPF v3. Again, process IDs. You can have multiple OSPF processes if you want. Activating interfaces is done in the router mode. So rather than going into the interface and doing IP router whatever, IPv6 router OF whatever, you go into the router OSPF v3 and then you do area 0 and then you list which interfaces sit in this area. So it's different, but that's how they chose to do it. And you've got the show commands, show OSPF v3, clear OSPF v3, and so forth. Looking at specific attributes, well, we can do show OSPF v3 and so forth. Doing the authentication, neighbor authentication, so again, similar to iOS, but slightly different. But again, the same idea, using the built-in IPsec. So here's a configuration example. I've taken exactly the same layout, same addressing, and given you the XR configuration instead. So I won't bore you by going through it precisely. But I mean, you notice how the router OSPF v3 configuration specifies each area and which interfaces sits in which area. Okay, and then looking at the v6 routing table, it looks the same as it did in iOS, pretty much. Configuring it in Junos. Well, in Junos, we go into the protocol section, we call it OSPF3 there. Then we specify the areas and which interfaces sit in which area. Then we've got various command modes, show OSPF3, clear OSPF3. If you're accustomed to using OSPF on Junos, it's pretty much OSPF3 instead. Now, configuring OSPF v3 on Junos, differences from iOS is no support for authentication, basically because it's not been specified in RFC 5340, and it's generally replaced by the v6 authentication header. I didn't actually get any configuration examples of what could be done, but I'm sure somebody will correct me at some stage. So, just doing a general configuration example, again, the same picture we had before. Configuration runs into two slides, so we've got the router 2 configuration there. It's sitting completely in area 1. So we go into the interface, we configure the address on the interface, we go into the router options to set the router ID, we go into the protocols, specify the interface fast Ethernet 300 is sitting in area 1, and we give it a metric of 100. On router 1, again, we set up the interface configuration, we specify the router ID, and then we go in and do the OSPF3 under the protocol section, again specifying in area 1 which interface is sitting there, and in area 0 which interface is sitting in there. I guess what XR has done is tried to follow roughly the idea of how Junos has configured OSPF3. Okay, so again, if you've done OSPF version 2 on Junos, this will look the same. And then looking at the routing table, again, you see the next hops are known via link local addresses. At least, it does tell you on the output which interface you're going to, but, well, I don't know. I find it's a bit challenging. Okay. As for doing OSPF v3 over tunnels, of course, the tunnel services pick is required to do that on both ends of the tunnel. Configurations for this particular scenario was, again, we set up the GRE interface, we set up the OSPF v3 protocol to run over the GRE interface, and that's pretty much an example configuration of how we do this. Okay, now let's look at ISIS. So I'm sure most of you use ISIS, know what it's all about. It's OSI, routing protocol for CLNS traffic. RFC 1195 added IP support. RFC 5308 added IPv6 address family support. RFC 5120 defines this multi-topology concept for ISIS, which I'm going to explain as I go through this. Okay, so we've got two TLVs added to introduce V6 routing. So basically this ISIS is multi-protocol. It's just a case of adding another protocol to it. So we add TLVs to handle IPv6. So we've got the V6 reachability, and we've got the V6 interface address. So looking at ISIS configuration example on iOS, well, wherever we have, well, we've got IPv4 ISIS already running, so we'll just call it router ISIS there. We've got an NSAP address there, that net 42001 and so forth. We're redistributing static into ISIS for whatever reason. And then we've specified address family IPv6, which basically handles the IPv6 piece of this. And then we just go to the interface, and where we have IP router ISIs to handle v4 ISIs, we simply add an IPv6 router ISIs to handling the IPv6 piece. So pretty much whatever you did for v4, you just do it the same for v6 and specify the v6 address family. You can run it over tunnels if you want. I'm not going to bore you with going through all this. So we'll try and move on to the next one. Let's look at XR. Similar concept as well. We've got router ISRs, as we've done for v4. We've specified the NSAP address. XR has a slight difference. We've got the different address families, so we can specify v4 unicast, v6 unicast. So we've got the v4 configuration there, the v6 configuration there. Note the single topology command. Now the reason I've done this is because iOS by default runs in single topology. It assumes that the v4 topology and the v6 topology are going to be exactly the same. So if you're using ISIS today and you want to deploy v6 across your network, you have to deploy it everywhere that you're running v4 and using ISIS. And this is a bit of an issue. It was a bit of an issue for some ISPs who want to do initial deployments. So to keep the configurations looking the same, I've made them look the same. So iOS default is to use a single topology. iOS XR's default is to use something called multi-topology, where basically the v4 topology can be different from the v6 topology. So I kind of have to turn off the default here by doing this single topology command. And then again, carrying on with the configuration, we then list all the interfaces that we have in the router, and then we specify which address family which interface is going to sit in, or which address family ISIS is going to run on for each interface. Moving on to Junos, quick reminder. So this again is going to spill over into two slides. So we first configure the interface. We give it its v4 address, that 10.111/24. We give it a v6 address, 201db8, whatever, /64. Family ISO means basically that you're going to be able to run ISIS on this interface. And then the rest of the configuration, this is the other fast Ethernet interface, we do the same piece. And we've got that's loopback interface also, similar thing. And we specify the NSAP address there. Then we head into the protocols section. We go into ISIS, because that's what we're configuring. We're doing the redistribute static just to make it look like the previous two examples. ISIS is going to run on the two fast Ethernet interfaces plus the loopback interface. And then we've got different policy statements there. So redistribute static policy statement basically says, well, from static routes, we're going to basically pop all the statics into ISIS. Okay, so that's pretty much how to do the same thing in Junos. Again, the whole thing with the tunnels, need the tunnel pick to run ISIS over IPv6 tunnels. Well, you need the tunnel pick to do tunnels. There's the configuration again, matching what I've shown earlier with the iOS example. Okay, so if we look at the multi-topology ISIS extensions, right, so what as I was saying before, ISIS for v6 assume that the v6 topology is the same as v4. That's how the first attempt at handling v6 on ISIS went. Which, well, you know, if you're deploying v6 across your entire infrastructure, dual stack, it's not a problem. But certainly some of the early adopters who started to look at this, maybe they want to do ISIS in a corner of the network or something, or handle v6 in a corner of the network, but, or maybe not run ISIS through some routers that just couldn't handle v6 whatsoever. They ended up having problems because you ended up with basically holes in the topology. So multi-topology ISIS came along, basically allowing you to run a completely separate infrastructure for v6 and v4. So that's now all specified, it's got a nice RFC to go with it. And so basically, multi-topology gives us two topology types, one for ISO v4 routing and the other one for v6 routing. And so generally you find, certainly in XR and Junos, multi-topology is actually the default. I think it's the default. So, I mean, they're the new TLVs that are specified, basically the multi-topology ones, which lets us carry the v6 prefixes separately. So looking at the configuration in iOS, first thing we have to do is, if you notice there, almost at the bottom of the configuration is, we need to enable wide metrics. I mean, pretty much anybody who's using ISIS these days is using wide metrics, but the iOS default is still to use the old narrow metrics from about a decade ago. So we need wide metric support, and we also need to specify multi-topology within the v6 address family. And doing that, everything else is pretty much the same as it was beforehand. What next? Okay, looking at XR, pretty much all that's changed here is the absence of the single topology keyword I showed you before, and the addition of the metric style wide in the v6 address family for ISIS. Otherwise, we have the same configuration, as I mentioned, with a single topology case. And in Junos, so this again is pretty similar as it was before. I'm trying to remember. I don't remember exactly what this was all about, but I don't remember. Ron jumped up last time we did the presentation, explained what this was, and I've forgotten what his explanation was about. But I believe that in Junos it's actually the default to do multi-topology and have wide metrics. Okay, moving on to BGP. So we have RFC 4760, which defines multi-protocol extensions for BGP. I mean, BGP in the early days, as you know, was just carrying v4 addresses, and then we had the multicast folks handling multicast information around within BGP, and the v6 folks then started adding v6 prefixes. So the need to carry multiple protocols within BGP became quite necessary. So multi-protocol BGP basically defines different address families to carry different types of protocols. 2545 actually specifies what the extensions are to handle v6. So 2545 is quite a low number, so it's been quite a while ago. It's probably about 96, 97, thereabouts. Basically when the 6-bone basically fell to pieces as far as I remember when it was using RIP-NG, and so the BGP handling v6 came out pretty quickly. So 4760 defines new optional non-transitive attributes. We've got this multi-protocol reachability NLRI and the non-reachability NLRI. And it carries information like the address family, so which address family we're in, the next hop information. Note this one, the next hop must be of the same address family. So this basically says, well, if you're going to carry a v6 prefix, the next hop address must be a v6 address. And then NLRI, of course, is the fancy word for, well, destination I'm trying to get to, route. And then the v6 specific extensions, well, you have, well, the next hop address. So you've got the sub-address family 1, which is the standard v6 unicast that we're all using. We've got sub-address family 2 for multicast RPF check. Sub-address family 3 is used for both unicast and multicast. And I forget what the label means for sub-address family 4. Rules for constructing the next hop. Well, when two peers share a common subnet, the next hop information is found by the global address and by the link local address. That's something to bear in mind. I mean, for v4, the next hop address was just the global v4 address. But in v6, if it's on the same subnet, the next hop address includes both the v6 routable address as well as this link local address. There's one RIB per protocol. Okay, that's important to remember again. I mean, obviously with the different address families, you'd expect there to be different routing tables. So the v4 routing table or the v4 unicast routing table sits in one place. The v6 unicast routing table is a completely separate thing. And you can apply different policies per protocol. So if you've got one set of aggressive filters for v4, they're not automatically carried over into v6. You need to set up another set of aggressive filters for v6 if you want to do that. So again, it's a bit like the security piece. When you're enabling v6 on your router, don't just assume that, well, because you've got nice filters in v4, they're going to be carried over. If you're setting up your BGP and you've got, carefully crafted filters for your peers and transits and so forth, if you're going to bring up a BGP v6 peering, you're going to need to craft similar filters. I mean, again, I've seen accidents happen where, somebody who's an end customer ends up providing transit for v6 by accident simply because they haven't got the filters done properly. So the next hop attribute, next hop contains a global v6 address, and it can contain a link local address as well. The link local address is only used as a next hop address if the BGP peer shares the subnet that both routers are sitting on. Okay, so watch out for that one. More considerations, BGP runs on top of TCP, of course. Connection can be made over v4 or v6, or both. When there's no v4 configured on the box, you need to set your router ID. Again, router ID is a 32-bit integer. You can come up with your own scheme for these 32-bit integers as long as they're unique in your network per router. And it's needed really. I mean, if you don't have the router ID, then BGP basically will not start. And you can go and try it out on different routers if you wish to see what, doesn't happen. So two options for configuring BGP. And this is the usual thing. If you go and read the documentation, you can see excited people saying, oh yeah, you can run BGP between FE80 addresses now. Isn't this cool? Well, yes it is, but bear in mind that FE80 addresses come from your MAC address, and if the Ethernet card or whatever on the neighboring router changes, the MAC address changes, and you get a new neighbor. So I really dislike the FE80 thing for BGP peering at all. That's why I have in big red letters saying, not recommended. Because, well, yes, you can do it, but just because you can do it doesn't make it the right thing to do. Use global unicast addresses. I mean, there are plenty of those. So just doing the regular peering, here's an example of a simple, eBGP peering. Now the first thing in iOS to note is there's no BGP default IPv4 unicast. I mean, I'm on the v6 ops mailing list and v6 users mailing lists and a few others, and I see people putting around iOS configurations with that one line missing. Now this one line basically means, well, it disables iOS's idea that every peer that you configure is going to be a v4 unicast peer. Okay, iOS default is basically, if you configure a BGP neighbor, I'm going to talk IPv4 unicast on this. Now, if you're going to set up a v6 only peering, you probably don't want the neighbor to try chattering v4 as well. I mean, if you miss this out, you'll end up with, if you look in the v4 address family, you see a peer, but there's no negotiation flag sitting on the show line. And it just ends up making your show output look really messy. You've got these configurations hanging around there that really aren't much use. And when you look at the configuration that's generated from the router, it basically ends up being substantially bigger than it needs to be because you have the v4 address family having every single v6 neighbor as well. Okay, so don't forget to do the no BGP default IPv4 unicast. And that switches off the assumption in iOS that each peer is going to be a v4 unicast peer. And then, of course, you've got the address family piece. So this is going to be changed. If you've never touched v6 at all in BGP and iOS, you're going to see that your configuration now changes. And again, people do the shock horror of, oh my gosh, what has it done? Because you get neighbor configurations up top, the generic stuff, and then you get v4 configuration, the v6 configuration, as we'll show you in a piece. So here we've got the address family IPv6. Notice the neighbor activate. And this says, this neighbor I want to activate for IPv6 address family. And then you've got your network statement and all the usual stuff. At least the network statement in v6 uses the modern slash notation rather than doing 255, 255, and so forth. Link local peering, I include this just to show you how evil it can look. If you want to do link local peering in v6, well, there you go. Neighbor FE80, :263 FF3043, :1143, activate. And if the neighboring router address changes, then you have to go and reconfigure peerings. And oh wait, you've got to also fix the next hop. So you've got to take a route map that actually fix the next hop to a real routable address, because you're going to pass this prefix around within your backbone. Well, this FE80 is of course only visible on the link. It's not visible across your entire backbone. So you end up with, if you don't do this, you end up with a classic IBGP error of unreachable next hop. So even though the peering comes up and you see prefixes, none of them will be reachable at all. So really do not do this. I should write on big letters, example only, do not do this. Okay? You'll see configuration examples talking about how to do it with link local. Please don't. In XR, okay, XR is different. So first thing, well, we've got the router BGP. We set the router ID by hand because that's what you need to do. iOS XR, like Junos, has inbound, outbound policy type configurations like this. I've shown here. Nice thing about XR, I think, is that you can't actually set up BGP and have it working without specifying inbound and outbound policy. Yippee, no more people setting up router BGP blah, neighbor blah, and getting full BGP table and sending full BGP table on to everybody else. You actually have to sit down and think about some policy. So this is quite nice, I think, being not really an XR user. So we've got some example of route policy there, and it's got just the route policy language, which pretty much says, well, this is my prefix, I want to announce it to the neighbor. Looking on Junos, pretty similar idea. We're configuring the addresses on the interfaces. We're popping a /48 or whatever it is. Well, we're setting it up as a static route, doing the router ID, and we're basically taking the static route and dropping it into BGP. So again, if you're familiar with Junos BGP configuration, pretty much all that's really happening here is the neighbor there specified as a v6 neighbor, and you're done. So dual stack, v4, v6 in iOS. This is what I was talking about a few minutes ago. When people first see this, if they're accustomed to running v4 only, and they suddenly they set up a v6 configuration, and the configuration file ends up looking something like this. They go, oh my gosh, it's broken it. What happens? What actually happens is when iOS goes multi-protocol and BGP, it separates the configuration out relevant per address family. So all the v4 address family relevant stuff, so things like filters, so we've got an inbound filter there and an outbound filter there, go into the address family. The network statement goes into the address family. The generic commands go up to the top. So neighbor statement there, even though the neighbor has got a v4 address, or maybe the neighbor's got a v6 address, with these neighbors you can still handle v4 or v6 prefixes as you wish. So you need to specify what each neighbor is going to actually handle. Then we've got the v6 address family, which is then being used to exchange v6 prefixes. And I've got an example of filters in here as well. I mean, if you're familiar with the IP prefix list for v4, well, surprise, surprise, we've got IPv6 prefix lists for v6. And the form is the same. We've got the usual ranging, slash notation, and so forth. One thing to note, and I find this confuses people as well, an IP prefix list is not the same as an IPv6 prefix list. You can actually use the same name, but where you use them is what matters. So if you go into a v6 address family and specify a prefix filter that's only defined for v4, as far as iOS is concerned, you have no prefix filter whatsoever. Don't fall into that trap. This is why I've actually done in this configuration, I've actually put v6 and v4 into the names of the prefix list. I find that as a useful visual reminder that you're filtering v4 prefixes for v4 peerings and v6 prefixes for v6 peerings. Again, I've just found this from experience of working with ISPs and doing workshops and so forth, that it's a visual reminder that helps keep people on the right path. Getting into XR, doing dual stack here, well, we've got the v4 address family network statement, the v6 address family network statement. We then specify the neighbors. We say which address family the neighbor is going to run in. So the 201.db8.1.1019 neighbor is sitting in address family v6. We've got the route policy that applies to it. And then the neighbor 172.16.1.2 is sitting in the v4 address family, the v4 unicast address family, and it's got that route policy as well. As you see, the route policy for XR is a bit more involved. But it's pretty much doing the same thing as the previous example for iOS did. So there's more configuration here, and that's a full piece. Okay, whoops, well, jumping too far. Yeah, right, so within Junos, again, we set up the interface addressing, we'll look at the route, well, going to the routing options, so we've set up our static route, for the /32, basically pointing to the null or the discard interface. We've set our router ID. We go into the routing protocols. We've set ourselves up in AS10. We're peering with AS20. That neighbor is in 10.1.1.2. There's no such concept as v6 or v4 address family. We're pretty much, the address family used is whatever the neighbor address is. So if the neighbor's in v4, then it's a v4 address family. If the neighbor's in v6, then it's a v6 address family. Okay, manipulating attributes. Well, in iOS, if you're accustomed to handling attributes for v4, it's, well, the same way for v6. I mean, if you notice there's a route map that basically sets a local preference. Now, this route map could be used for v4 peering and could be used for v6 peering because nothing in that route map is dependent on v4 or v6. So there's an example of just setting a local pref on prefixes we hear from this particular neighbor. Okay, and doing the same thing in XR. So again, router is sitting in AS1. The neighbor 2:2 is sitting in AS2. 2:2 is sitting in AS3. We've got the route policy from AS2, and we've got a route policy from AS3 as well. So the from AS2 route policy is pretty much setting the local pref 120 for prefixes learned, whereas the route policy from AS3 is pretty much just letting everything in without touching it. Within Junos, again, 2 slides to show this one. So the router in AS1, the BGP configuration there, we specify the neighbor in AS2. We're taking the static route and punting it out to AS2. Neighbor, v6 neighbor. The AS3 peer is also taking the static route, announcing it out to them. And then we've got the policy options. Again, we're doing the export, we're setting local pref as appropriately. I think that's right. Whereas, setting local pref 120 in one peering, we're setting local pref 100 on the other peering. Now, carrying v4 inside a v6 peering, you can do this in iOS if you want to. You can actually carry v4 prefixes. But remember to stay compliant with the rules. The next hop must be in the same address family. So what will actually happen if you carry the v4 prefixes, they'll have a v6 next hop, which of course is not legal. So when we get the prefixes, as you see in the last line there of the route map, we have to fix the next hop to make it a v4 address. So if you actually want to save, I don't know, peering real estate or router configuration real estate or chatter between the peers, rather than setting up 2 peers to handle v4 and v6 prefixes, you can just set up 1 peering over v6 and transport both your v4 and v6 prefixes. But note, must remember to set the next hop, otherwise you end up with an invalid next hop and no reachability. Okay, and doing this in XR, you can do the same thing. Again, you've got the particular RPL language stuff, but you have to set the next hop appropriately, otherwise things won't work. Now for Junos, it works the other way around. They can carry v6 prefixes in a v4 peering, but cannot carry v4 prefixes in a v6 peering. So, okay, the status commands, looking at iOS and XR, they actually share the same status commands that show BGP IPv6, unicast, which will show you the unicast routing table for v6. So there's a show BGP IPv6 unicast for a particular prefix. And you see the neighbor they actually learn the prefix from. That's not a mistake on the right, the 101022, that is the router ID of that particular peer. And the router ID is a 32-bit integer. It just so happens to be displayed in the dotted quad format. Note I've got the show BGP IPv6 commands there in iOS and XR. You can do show BGP IPv4 as well. So that command compatibility is also there. And otherwise, if you're familiar with the iOS show command, show BGP IPv6 unicast summary, there's one reason I like short addresses for the neighbor. I mean, if you have long addresses, then the line splits into two pieces, which some people parse this output and lines split into two pieces just starts getting messy and difficult to handle. So if you've got short neighbor addresses, then, well, not only is it easier to type and harder to make mistakes, it just looks prettier on the screen. Unless you go give yourself a wide screen. But that's the sort of display you get. BGP activity, who you're peering with, prefixes received, and so forth. With an XR, so there's an example of a long address. It splits the line, and it just looks a little bit strange. With an Junos, show BGP summary. So we've got the INET6 address family sitting there. Again, we hear the neighbor coming from AS103, peering established, and the number of prefixes handled, and so forth. They are somewhere. Okay. And then the show BGP neighbor, it's a full detail of the neighbor. So you can see how the adjacency has been negotiated, the amount of traffic, and so forth. Okay, so conclusion about all that. BGP has been extended to support multiple protocols, so v6 is but one more address family in all this. Operators who are experienced with v4 BGP should have no trouble adapting at all. As I say, it's pretty much what you're accustomed to. Again, depending on the platform, you just have to throw in address family commands, remembering to switch default expectations and so forth. So I would say anybody who's happy with handling v4 should be able to handle v6. So summary of all this, routing protocols in v6 behave as they do in v4. 96 more bits, no magic, Garob's gone, but that was one of the phrases he's coined and he has the t-shirt. It really is. I mean, certainly when I've been doing workshops, the biggest concept that people have trying or struggle with is doing the addressing, handling the big numbers, trying to mentally handle /32s and /64s and point-to-point links and so forth, coming up with reasonable addressing plans. But actually doing the routing protocols, well, okay, it's a neighbor, whether we're typing numbers with colons and numbers with dots, well, it's just a number. The policies are all the same and so forth. So certainly as far as routing protocols go, v6 is basically v4 with really big addresses. Most organizations are going to deploy v6 dual stack alongside existing v4. I don't imagine anybody is going to just go v6 pure for many years yet. So it's simply a case of just adding v6 functionality to the existing network. And that is all I have for you. Are there any questions at all? As I was saying at the start, if there are other implementations who want to contribute bits and pieces, I will be delighted to include. If there are mistakes in this, I'll be delighted to fix them.
Hi, Richard Steenberg at Inland. So we actually use, in the example that you showed with one BGP neighbor carrying two address families, we use that without rewriting the next hop, and it works fine.
It did, okay.
It's actually weird. Cisco handles it properly when you originate a route. If you're doing next hop self, if it's going into a v6 address family, it will use the v6 address off the loopback. You actually have to work around this with Juniper because it does not do that. So it will take a v6 route that you originate from a Juniper and try to stick a v4 next hop on it.
Okay.
So the cheap workaround for that is to configure a a Juniper v6 alias that is : your v4 address.
Okay.
And one other comment, what we use for numbering, which I think has worked really well for v6, is to take the v4 address. So say, for example, you've got a 32 or whatever you've got from Aaron or whoever. So we take like our 2001 :590 : and then you put the v4 address in, and then you do / whatever the v4 mask would be plus 96. So literally, you're just mapping your v4 address into hex into v6. And the trick for this is anywhere that you already have v4, you don't have to think about allocating it. You don't have to update your tools. You can just copy your DNS settings right over, so all your DNS in v6 magically works. It's really, really convenient. And as long as you're running dual stack v4, v6, I highly recommend people do that. It just saves so much grief.
No, that's a really good tip. Yeah, thanks, Richard.
Phil.
Your voice came from there.
How about that? Talking Pete Temple and Texan Communications, talking about ISIS multi-topology. Have you worked with anybody who's done a v6 rollout using ISIS?
Yes.
Because we ran into horrendous problems, and it may have simply been that maybe step one is run around to all your routers and drop in multi-topo.
Okay.
Because when we went to our first router, we set the overload bit, pushed it out of the forwarding path, and the moment I tried to enable ISIS on the loopback, that router fell off the face of our network, v4 and v6.
Well, the ones I've worked with, I'll have to check and see whether they're doing multi-topology or not. I suspect not, because I think they rolled out dual stack everywhere. So I would check.
It just seemed as though ISIS said, your topologies don't agree.
Oh, okay.
And blew up that box. I mean,
Wow.
reload in 20 was a nice rescue, as was console access.
Yeah, yeah.
So there's a transition mode for multi-topology that you can turn on. So Cisco will look to see if both the neighbors are speaking multi-topology or not, or single topology. And you can disable that check by turning on the transition mode on Cisco. Juniper actually doesn't do that check, so there's no need to do a transition mode. But that's what will keep your ISIS from dying during that transition.
But I didn't think my loopback had any neighbors. And the moment I stuck ISIS on the loopback.
Right, but it's been a while, it's been a few years since I did this, but I believe once you put on v6 on an interface on that router, then it starts sending the v6 in the ISIS LSAs, and so all of your routers that aren't expecting that will puke on it.
Okay.
So it's like it's been a couple of years, but there is that transition mode that will assist with that. And then so basically you go and you put on the transition mode on everything, get everything up to multi-topology, and then go back in and back out the transition mode, and you're good to go.
Yeah, we went to plan B, which was to actually roll back to OSPF. But we had other driving reasons behind that.
Yeah, that would be the transition keyword that I've put in the bullet there, not actually mentioned, wouldn't it?
Okay.
I think that's what that would be. Okay.
Hi, Chris DeYoung, University of Arizona. If we're at the point of just getting ready to roll out our IPv6, and with the understanding that we only need to run it on Cisco boxes, ERGRP looks like it's by far the easiest to set up. Is there any reason that I would want to seriously look at doing something other than that for my IGP? What do you recommend as far as selection?
If you're using ERGRP at the moment, I would say why change? But there are plenty of people in the audience who use OSPF and ISIS for various reasons and probably good reasons. So I know people who have actually moved from OSPF to ISIS just so they can deploy IPv6, for example. And I've known people who have moved from ERGRP, because ERGRP came very late to the game with v6 support. It's like only, 2 years now? So it's been pretty late. But I don't know. I tend to think, you're comfortable with ERGRP. It's not broken, so I don't think there's any need to fix it. But, there have been plenty of good tutorials here about, merits of OSPF ISI. So if you want to consider changing completely, I'd rather look at that. I don't want to get into which is better. So, but, ERGRP should work just fine if that's what you have.
Thanks, Phil, for the wonderful presentation. I know that Cisco has IOS XE also. Does it
Yes.
follow the same V6 pattern what we have seen in XR?
I don't know. I might quote this wrong. I believe iOS XE would look like iOS more. I would need to check. I haven't had a chance to play with it yet. And same the Nexus switch, NXOS, I don't know what it looks like there either. So next time I do this, I'll try and get that all updated.
Dwight Ernest from R&K Communications. If I've got a bunch of 723Bs deployed, and I'm close to my 239K route IPv4 unicast limit, and I deploy a significant IPv6 RIB, is that going to use up resources in that same pool, or is it a separate pool?
It will use up from that pool. Yeah. I mean, what they're about, depends where you look, there are about 1,500 prefixes in v6. So we added about 800 in the last year or so. So I'd expect that number to go up a bit quicker now. So yeah, I'm sorry, it's what was talked about earlier on today about how to try and reduce the number in there to maintain that hardware. I mean, yeah, you can go and speak to your friendly sales guy. He'll be delighted to sell you something bigger, but I think, it makes more sense to try and get keep existing functionality and so forth. So, I mean, yeah, without going into a rant, trying to pare away about this 55% of prefixes that really don't need to be there is probably a good policy first. No other questions? Yeah.
Back to the issue with the 720Bs, and I could be incorrect on this, but you're saying that the IPv4 and the IPv6 tables share the same memory and have the limitations?
Yep.
It seems to me that there was, several years ago, we ran into the issue with the 720Bs not being able to carry the full route table, and one of the workarounds was that to actually steal memory space from the IPv6, where the IPv6 was held, in order to increase what you could have in the IPv4 as a temporary workaround, which leads me to believe that they're in separate memory spaces.
Testing my knowledge on the 3B. Oh, if you can answer, Richard, yeah, please.
Yeah, I can answer that. So it's the same TCAM, but you can statically configure where it gets allocated. And keep in mind that v6 addresses, so an IPv4 address, it goes into a 72-bit TCAM entry. A v6 address goes into a 144-bit. So every v6 route counts for double what a v4 route does.
But yes, there is actually a finite space, and it depends how you chop it up. No other questions? If not, Joel is coming to the mic.
Yeah, just in terms of the amount of CAM space you actually need for your v6 routes at the moment, there's only like 1,400 of them. So the fact that you don't have much space doesn't necessarily impact you. I mean, you'll still be stealing space from your v6 CAM for a while for v4.
Yeah.
I would expect it to double in size every 2 years, just like the v4 one does, if not faster. But, that means 5,000.
Well, I mean, the v6 table showed it's getting on for about 80% growth in a year, which I don't think the v4 one has ever done.
Yeah, the v6, as a percentage, on a percentage basis, the v6 table is growing faster than the v4 table. It's just obviously starting from a smaller base.
Yeah. Okay. We have no other questions. Should I remind you all again to go and vote? I'm sure you'll be bored with all these announcements, but anyway. I'm told that, people never find where to go and so forth. So, again, please go and vote. Steering committee, 7 candidates, 3 positions, the 3 charter changes. So again, have a look at those, have a read about them. It's all accessible through the election page there. You need your NANOG login to the one you use for registering to go and vote. So please go and do that. Todd will nag you again tomorrow morning about it, and Betty no doubt will nag as well during the break, and you'll be reminded before lunch also that polls are about to close, so if you please go and do that. Anyway, so what remains this evening, we've got beer and gear, that's starting at 6 o'clock in the Crystal Room, and after that we've got social event hosted by CRG West, Extreme and Zimmer. In the standard and in the rooftop lounge. So I don't know how we get to that. I guess there'll be maps at the registration and so forth. So that's the plan for this evening. You've got 5 minutes to get to the Crystal Room. See you tomorrow.